My dear students, welcome back to our channel. Students, in this video I am explaining JNTUH Hyderabad MBA third semester subject MIS short and long important questions one by one. Let's start with first unit. First important short question is define MIS. A management information system. MIS is a system that collects, processes, and organizes data to help managers make informed decisions. It provides regular reports and summaries, often focusing on performance metrics like sales, inventory, or employee productivity. For example, a monthly sales report generated by an MIS helps managers analyze trends and adjust strategies. MIS makes decision-making easier by converting raw data into useful information. In short, MIS is essential for guiding day-to-day operations and strategic planning within an organization, improving efficiency and effectiveness in decision-making. First important long question is different types of information systems. Information systems, IS, are essential for managing data and helping organizations operate efficiently. They involve a set of interconnected components that collect, process, store, and distribute information. There are several types of information systems, each serving different functions and needs within an organization. Let's break them down with examples for clarity. 1. Transaction Processing System, TPS. This type of system helps with the day-to-day operations of an organization by handling routine transactions. For example, a point of sale, POS, system in a retail store records customer purchases, tracks inventory, and processes payments. These systems are critical for efficient business operations. 2. Management Information System, MIS. An MIS provides middle-level management with reports and summaries of organizational activities, often focusing on monitoring performance. For example, a sales report generated by an MIS helps managers track sales trends, evaluate employee performance, and make informed decisions to improve efficiency. 3. Decision Support System, DSS. A DSS helps managers make decisions by analyzing large volumes of data and presenting different alternatives. An example would be a business intelligence BI tool that analyzes market trends, customer preferences, and sales data to guide strategic decisions like launching new products or adjusting marketing strategies. 4. Executive Information System, EIS. An EIS provides top executives with easy-to-read reports and dashboards, often offering a high-level overview of the organization's performance. For example, a CEO might use an EIS to monitor key metrics like revenue, customer satisfaction, or operational costs in real time. 5. Expert System, ES. These systems mimic human expertise to solve complex problems by reasoning through bodies of knowledge. A common example is a medical diagnostic system that helps doctors diagnose diseases based on symptoms and medical history. 6. Enterprise Resource Planning, ERP, system. ERP integrates core business processes like accounting, HR, and supply chain management. An example would be SAP ERP, which allows a company to manage everything from procurement to payroll in one unified system. In conclusion, information systems help organizations perform better by streamlining operations, supporting decision-making, and providing useful insights. Each system has a distinct role and caters to specific levels within an organization, ensuring data is efficiently managed and utilized for better business outcomes. Next important long question is discuss about managerial challenges of information technology, IT. Information technology, IT, plays a crucial role in modern organizations, but it also brings several managerial challenges that need careful attention. These challenges can affect everything from decision-making to day-to-day operations. Let's look at some of the key challenges faced by managers in relation to IT. 1. Security and privacy. With the increasing amount of sensitive data stored online, ensuring the security and privacy of information is a major concern. For example, a data breach in an e-commerce company could lead to the exposure of customer credit card details, resulting in financial loss and damage to the company's reputation. Managers must invest in strong security measures like encryption, firewalls, and regular audits to safeguard against threats. 2. Constant technological change. Technology evolves rapidly, and keeping up with new advancements can be overwhelming. For example, businesses that rely on outdated software may face inefficiency or struggle to compete with competitors using the latest tools. Managers must continuously evaluate and adopt new technologies to stay competitive, which requires both time and investment. 3. Integration of IT systems. As organizations grow, integrating various IT systems and platforms can be complex. For instance, a company using separate systems for inventory management and customer relationship management (CRM) may face difficulties in ensuring data consistency. Managers must find ways to integrate these systems smoothly, often through enterprise resource planning (ERP) software, which requires careful planning and expertise. 4. Employee training. Implementing new IT systems often requires employees to learn how to use them effectively. For example, if a company introduces a new customer management system, employees will need training to maximize its potential. Without proper training, employees might resist the new system or use it inefficiently, which could impact productivity. 5. Cost management. IT investments can be expensive. Managing the costs associated with purchasing, maintaining, and upgrading technology is a critical challenge. For example, maintaining a data center or paying for software licenses can put pressure on budgets. Managers need to find ways to balance cost with the benefits that IT provides, ensuring a return on investment. In conclusion, while IT offers vast opportunities for efficiency and growth, it also presents challenges that managers must address. From security concerns to managing costs, staying ahead of technological changes and ensuring effective use of IT systems, these challenges require strategic planning, foresight, and continuous investment to overcome. Next important long question is explain the components of information system resources and activities. An information system, IS, is made up of several key components that work together to collect, process, store, and distribute data effectively. These components include hardware, software, data, people, and processes. Let's break down each of these components and their roles. 1. Hardware. This refers to the physical devices that are used to collect, store, and process data. Examples include computers, servers, networking equipment, and storage devices. For instance, a company's server stores the database that supports its website, while employees use personal computers to access and interact with this data. 2. Software. Software is the set of programs that instruct hardware on how to perform tasks. It can be divided into two categories: system software, such as operating systems, and application software, like business management programs. For example, an inventory management system helps a business track product stock, while Microsoft Windows manages the operation of a computer. 3. Data. Data is the raw material that is processed into useful information. It could include numbers, text, images, or even sound. For example, customer data such as names, addresses, and purchase history is collected by an e-commerce site and processed to make decisions about marketing or product recommendations. 4. People. People are crucial to the functioning of an information system. They include IT professionals who design and maintain systems, as well as end users who interact with the system daily. For example, a data analyst interprets reports from an information system to provide valuable business insights, while a manager might use those insights to make decisions. 5. Processes. Processes are the series of steps or activities used to collect, process, and distribute data. These can include decision-making processes, workflows, and routines. For example, a company's order processing system includes the steps of receiving an order, checking inventory, invoicing, and shipping the product. In conclusion, an effective information system relies on the coordination of hardware, software, data, people, and processes to ensure that the right information is available at the right time. Each component plays a unique but interconnected role in helping organizations function smoothly and make informed decisions. Next important long question is, in what way information systems is used for collaboration and social business? Information systems are increasingly used for collaboration and social business by enabling individuals and teams to work together more efficiently, share knowledge, and communicate in real time, regardless of geographical location. Here are some ways these systems support collaboration and social business. 1. Communication tools. Information systems provide various platforms for communication, such as email, instant messaging, and video conferencing. These tools allow team members to discuss ideas, share updates, and resolve issues quickly. For example, a team in different countries working on a product development project can use tools like Zoom for video calls or Slack for instant messaging to stay connected and collaborate in real time. 2. Document sharing and management. Collaborative information systems enable teams to create, edit, and share documents easily. Platforms like Google Drive and Microsoft OneDrive allow multiple users to work on the same document at the same time, making collaboration seamless. For instance, a group of employees can work together on a marketing plan, where everyone can edit, comment, and contribute to the document from different locations. 3. Social media and networking. Social business involves using social media tools and networks to enhance collaboration, build relationships, and engage with customers. Information systems help companies create online communities where employees, partners, and customers can interact. For example, a company's LinkedIn group can be used to share industry news, ask questions, or collaborate on projects with industry peers. 4. Project management tools. Information systems also include specialized software that helps teams manage projects, assign tasks, track progress, and meet deadlines. Tools like Trello and Asana enable team members to track who is responsible for what and when tasks are due. For example, a software development team can use these platforms to manage tasks, track bugs, and communicate on project milestones. 5. Crowdsourcing and open innovation. Information systems facilitate collaboration with external parties through crowdsourcing or open innovation platforms. For example, a company might use a platform like Innocentive to tap into a global network of problem solvers for innovative ideas. In conclusion, information systems are vital for enabling collaboration and supporting social business. They connect people, streamline communication, and foster teamwork, which ultimately leads to increased innovation, productivity, and stronger relationships within and outside an organization. Next important long question is, how can we use information systems for strategic advantages? Information systems can be powerful tools for gaining strategic advantages by helping organizations make better decisions, streamline operations, and stay ahead of competitors. Here's how they can be used effectively. 1. Improving decision-making. Information systems provide data that helps managers make informed decisions. For instance, a business intelligence (BI) system analyzes sales data, customer trends, and market conditions, enabling executives to decide which products to focus on or where to expand. A company like Amazon uses data analytics to personalize recommendations, optimizing customer experiences and boosting sales. 2. Enhancing efficiency. By automating and optimizing business processes, information systems can significantly reduce operational costs and improve efficiency. For example, an enterprise resource planning (ERP) system integrates various business functions such as accounting, human resources, and supply chain management, allowing a company to streamline workflows and reduce redundancies. Walmart uses an ERP system to manage its vast supply chain and ensure products are delivered on time at the lowest cost. 3. Gaining customer insights. Information systems help businesses collect and analyze customer data, enabling them to understand preferences and needs. With this information, companies can tailor their marketing strategies, improve customer service, and even develop new products. Netflix, for example, uses data collected from user viewing habits to recommend personalized content and create original shows that attract more subscribers. 4. Competitive advantage through innovation. Information systems can drive innovation by enabling new business models or services. For instance, companies like Uber and Airbnb leverage information systems to provide platforms for ride-sharing and short-term rentals, disrupting traditional industries. This innovation not only meets customer demands, but also creates a unique value proposition that competitors struggle to replicate. 5. Global reach and flexibility. Information systems enable companies to expand their reach beyond local markets. For example, an e-commerce platform like eBay allows sellers from around the world to connect with buyers globally, opening up new revenue streams and markets that would be difficult to access without technology. In conclusion, information systems play a crucial role in gaining a strategic advantage by enhancing decision-making, improving efficiency, offering customer insights, fostering innovation, and enabling global expansion. When used effectively, they can help businesses outperform competitors and achieve long-term success. To next second unit first important short question is ERP system importance in business. An ERP, enterprise resource planning, system integrates various business processes such as finance, HR, sales, and supply chain into a single system. This centralization helps businesses streamline operations, improve efficiency, and make data-driven decisions. For example, in a manufacturing company, ERP can track inventory, manage orders, and monitor production schedules in real time, reducing errors and delays. This leads to cost savings and better customer service. In conclusion, an ERP system is crucial for businesses to stay organized, improve productivity, and remain competitive by automating processes and ensuring accurate, up-to-date information. Second unit, first important long question is explain about customer relationship management. Customer relationship management, CRM, refers to strategies and technologies used by businesses to manage and analyze customer interactions and data throughout the customer lifecycle. The goal is to improve business relationships, enhance customer satisfaction, and drive sales growth. CRM systems help businesses streamline processes by storing detailed customer information, including contact details, purchase history, preferences, and interactions. This data allows companies to tailor their marketing efforts, provide personalized customer service, and anticipate customer needs, improving the overall experience. For example, imagine a retail company using a CRM system. When a customer makes a purchase, the CRM records their details, such as the items bought, spending habits, and preferences. Later, when the customer contacts the company for support, the CRM enables the support team to quickly access the customer's history, offering faster, more efficient service. Additionally, the CRM can send personalized promotional offers based on the customer's purchase history, making marketing efforts more relevant and increasing the chance of repeat sales. A CRM system is also valuable for tracking sales leads and managing the sales pipeline. It helps sales teams organize prospects, monitor communication, and follow up with leads at the right time, ultimately boosting sales efficiency. In conclusion, CRM is crucial for businesses that aim to foster long-term, loyal relationships with their customers. By centralizing customer data, businesses can provide more personalized, efficient service and improve decision-making, ultimately leading to better customer satisfaction and increased profitability. A well-implemented CRM system not only helps businesses stay connected to customers but also enhances their ability to grow and adapt in an ever-competitive market. Next important long question is discuss about ERP systems and their modules. An ERP, Enterprise Resource Planning, system is a software that integrates various core business functions into a unified system, helping businesses manage and automate their processes. This integration allows for more streamlined operations, better communication between departments, and accurate, real-time data to support decision-making. ERP systems consist of several modules, each focusing on different aspects of business operations. Here are some key modules typically found in an ERP system. 1. Finance and Accounting. This module helps track financial transactions, manage accounts payable receivable, and generate reports like balance sheets and income statements. For example, a company can easily track expenses, revenues, and ensure financial compliance. 2. Human Resources, HR. This module manages employee information, payroll, recruitment, training, and performance evaluations. It simplifies HR tasks like calculating salaries, tracking attendance, and ensuring compliance with labor laws. 3. Sales and Customer Relationship Management, CRM. This module helps manage sales orders, customer interactions, and customer support. It tracks the sales process from lead generation to closing the sale, helping improve customer relationships and increasing sales. 4. Inventory and Supply Chain Management. This module monitors stock levels, procurement, and supplier relationships. For instance, a company can track the quantity of raw materials, manage warehouse operations, and ensure timely procurement. 5. Manufacturing and Production. This module helps manufacturers plan production schedules, manage resources, and optimize the manufacturing process. It tracks inventory levels, production costs, and quality control to ensure timely and cost-effective production. 6. Procurement. This module helps businesses manage the acquisition of goods and services, from purchase order creation to vendor payment. It helps ensure that purchases are made efficiently and cost-effectively. Example, a company that sells products online might use the ERP system to track customer orders, sales module, manage inventory module, process payments, finance module, and handle employee payroll, HR module, all in one integrated system. In conclusion, ERP systems are essential tools for businesses seeking efficiency and scalability. By using different modules, businesses can improve workflows, reduce errors, and make informed decisions that support growth and success. Next important long question is, what is DSS? Explain its components. A decision support system, DSS, is a computer-based system designed to assist managers and decision-makers in making informed decisions by analyzing large volumes of data and presenting relevant information. A DSS helps in solving complex problems that require judgment, evaluation, and problem-solving, especially in situations where there is no clear solution. Components of a DSS. 1. Database Management System, DBMS. This is where all the relevant data is stored and organized. It includes historical data, transactional data, and external data. For example, a retail company's database could contain customer data, sales records, inventory levels, and market trends. 2. Model Management System, MMS. The MMS helps in processing data and providing models to assist with decision-making. These models could include statistical, financial, or forecasting models. For example, a company might use a financial model to assess the impact of various pricing strategies on profitability. 3. User Interface, UI. The UI is the part of the DSS where users interact with the system. It presents data, models, and analysis results in a user-friendly format. Managers or decision-makers can input queries, view reports, and adjust variables. For example, a manager might input different sales forecasts to see how they impact future revenue. 4. Knowledge Base. This is a repository of business rules, best practices, and expertise that can be used to support decisions. The knowledge base helps provide context and guidelines for decision-making. For example, a company might use guidelines on customer segmentation to make marketing decisions. Example, imagine a company that is deciding on launching a new product. The DBMS provides market research data, sales history, and consumer behavior. The MMS helps in analyzing this data through forecasting models to estimate potential sales. The UI allows managers to test different scenarios, such as pricing options and promotional strategies. The knowledge base contains information on past product launches and industry best practices. Conclusion. In summary, a decision support system, DSS, is an essential tool for decision-making in complex scenarios. It integrates data, analytical models, and user-friendly interfaces, empowering businesses to make better-informed decisions. By combining all these components, a DSS provides valuable insights that enhance decision quality and organizational performance. Next important long question is, explain about business intelligence. Business intelligence, BI, refers to the technology, tools, and processes that businesses use to collect, analyze, and present data to help make informed decisions. It involves turning raw data into meaningful insights, which can improve decision-making, optimize operations, and drive business growth. Key components of BI. 1. Data collection. BI systems gather data from multiple sources, including databases, spreadsheets, customer interactions, and external sources like social media or market reports. For example, an online store might collect data from customer orders, website traffic, and social media feedback. 2. Data analysis. After data is collected, it's processed and analyzed. This step uses techniques such as statistical analysis, data mining, and predictive analytics to uncover trends, patterns, and relationships. For example, BI tools could analyze sales data over time to identify which products are trending or which customers make repeat purchases. 3. Reporting and visualization. Once data is analyzed, By tools present the findings through easy-to-understand reports, dashboards, and visualizations, charts, graphs, etc. This helps users quickly interpret the data. For example, a manager might view a dashboard showing sales performance across regions or a graph comparing monthly revenue growth. For decision-making support, the insights provided by support business decisions, such as improving marketing strategies, forecasting demand, optimizing supply chains, or identifying new growth opportunities. For example, a company could use BI to decide which new products to launch based on market trends and customer preferences. Example, imagine a chain of coffee shops. BI tools could help the company analyze sales data to determine which locations are performing best, what time of day customers make the most purchases, or which menu items are most popular. This information helps the company make data-driven decisions, such as adjusting staffing schedules, offering promotions, or introducing new menu items. Conclusion: business intelligence is essential for organizations that want to make data-driven decisions. By transforming raw data into actionable insights, BI helps businesses improve efficiency, increase profitability, and stay competitive. It enables companies to understand their performance and make smarter, more informed decisions. Next important long question is explain about Knowledge Management System. A knowledge management system, KMS, is a technology-based system used by organizations to store, share, and manage knowledge and information. The goal of a KMS is to make it easier for employees to access valuable knowledge, collaborate with each other, and leverage existing information to improve decision-making, innovation, and overall business performance. Key components of a KMS: 1. Knowledge repository. This is the central database or storage where all types of knowledge, documents, reports, manuals, FAQs, best practices, etc. are kept. It's organized in a way that allows easy retrieval. For example, an IT company might store troubleshooting guides, software manuals, and coding templates in a knowledge repository. 2. Collaboration tools. KMS includes tools for sharing information and collaborating, such as discussion forums, chat platforms, and document sharing systems. These tools help employees exchange ideas, ask questions, and solve problems together. For example, a marketing team might use an internal forum to brainstorm and share new campaign ideas. 3. Search and retrieval. This feature allows employees to search for and retrieve relevant information from the knowledge repository. Advanced search features help users quickly find the knowledge they need. For example, a customer service representative can search for product FAQs or troubleshooting steps when helping a customer. 4. Knowledge sharing and creation. A KMS supports knowledge creation by allowing employees to add new information and share their expertise. It might include tools for creating new documents or updating existing ones. For instance, a senior manager could share insights on handling difficult customer complaints, contributing to the company's overall knowledge. Example: consider a consulting firm that uses a KMS. The company stores case studies, research reports, and client-specific knowledge in the system. When a consultant works on a new project, they can access relevant past case studies, collaborate with other consultants through discussion forums, and find useful templates in the knowledge repository. This reduces the need to reinvent the wheel and speeds up project delivery. Conclusion: a knowledge management system, KMS, helps organizations capture, organize, and share knowledge effectively. By creating a centralized platform for storing and sharing information, a KMS enhances productivity, promotes collaboration, and ensures that valuable knowledge is accessible when needed. This ultimately leads to better decision-making, innovation, and competitive advantage. Next, Unit 3. First important short question is, what is Information System Planning? Information System Planning, ISP, is the process of aligning an organization's information systems with its business goals and strategies. It involves identifying the technology, resources, and systems needed to support business operations effectively. The goal is to ensure that the organization's IT infrastructure is scalable, efficient, and can adapt to future needs. For example, a retail company may plan an information system to manage inventory, track sales, and handle customer data. In conclusion, ISP helps businesses identify the right technology solutions to enhance operations, improve decision-making, and drive growth. Next important short question is, write note on Nolan's 6-stage model. Nolan's 6-stage model outlines the stages an organization goes through as it develops its information systems, IS. The stages range from initiation, where systems are basic and informal, to maturity, where systems are fully integrated and strategic. 1. Initiation, early, uncoordinated use of IT. 2. Contagion, rapid, uncontrolled adoption of IT. 3. Control, efforts to standardize and manage IT. 4. Integration, systems are interconnected. 5. Data administration, focus on managing data across the organization. 6. Maturity, fully optimized and strategic use of IT. For example, a small business may initially use basic software, Stage 1, and evolve to fully integrated systems, Stage 6, as it grows. Next, third unit. First important long question is, discuss the need for system planning and acquisition. System planning and acquisition is a critical process for any organization that wants to ensure its information systems effectively support business objectives. This process involves identifying the technology needs of the organization, designing a system to meet those needs, and acquiring the necessary hardware, software, and services. Without proper planning, an organization risks investing in the wrong systems, leading to inefficiency, wasted resources, or missed opportunities. Why system planning is necessary? 1. Alignment with business goals. Proper system planning ensures that the technology chosen aligns with the organization's overall strategy and goals. For example, if a retail business is expanding, it may need an upgraded inventory management system to handle increased product flow and improve customer service. System planning ensures the right technology is in place to support this growth. 2. Cost management. By carefully planning the acquisition, organizations can estimate the total cost, including upfront costs, maintenance, and potential upgrades. This helps avoid overspending. For instance, a company might initially consider a cloud-based system but realize through planning that an on-premise solution would be more cost-effective in the long run. 3. Risk reduction. Effective planning helps in identifying potential risks, such as system integration challenges or data security issues. For example, a financial services company needs to ensure that its new system complies with regulatory requirements and protects sensitive client data. Planning reduces the likelihood of disruptions or costly mistakes. 4. Optimizing resources. System planning ensures that the necessary resources, personnel, hardware, and software are available and optimized for use. If a company adopts new software, proper planning ensures that employees are trained and that the system is integrated smoothly into daily operations, minimizing downtime. System acquisition. Once the planning is complete, organizations must acquire the required systems. This involves selecting suitable vendors, negotiating contracts, and making purchase decisions. For instance, a business might decide between two software vendors after comparing features, costs, and support services. Conclusion: in summary, system planning and acquisition are vital for ensuring an organization's IT systems effectively support its business needs. By carefully planning and selecting the right technology, businesses can enhance productivity, reduce risks, optimize costs, and ensure long-term success. Next important long question is, what is system acquisition? Explain the hurdles involved in its. System acquisition is the process of identifying, evaluating, selecting, and purchasing information systems or technology solutions that meet an organization's needs. This process involves several steps, from defining the requirements to choosing a vendor and implementing the system. A successful system acquisition ensures that the chosen system will improve efficiency, support business goals, and integrate well with existing technologies. Hurdles in system acquisition. 1. Lack of clear requirements. One of the major challenges in system acquisition is failing to clearly define the organization's needs. Without a detailed understanding of what the system should do, the wrong system may be selected. For example, a company may purchase software that doesn't scale as their business grows, leading to future inefficiencies. 2. Vendor selection. Choosing the right vendor can be difficult, as there are many options available in the market. It can be challenging to evaluate vendors based on factors like features, pricing, customer support, and reputation. For instance, a company may face confusion between two vendors offering similar products, but with different pricing models and support services. 3. Integration issues. A new system must integrate smoothly with existing infrastructure. If the new system doesn't work well with other software or hardware, it can disrupt business operations. For example, a company may acquire a new customer relationship management (CRM) system that doesn't integrate well with its existing accounting software, leading to data inconsistencies and workflow disruptions. 4. Training and adoption. Even with the best system, employees need training to use it effectively. Resistance to change is a common hurdle, as employees may be reluctant to learn a new system. For example, a factory may implement an inventory management system, but if employees are not adequately trained, they may continue to rely on outdated methods, reducing the system's potential benefits. 5. Cost overruns and delays. System acquisition can be costly, and projects may face budget overruns or delays. A lack of proper planning and resource allocation often leads to unexpected costs. For example, custom-built software may cost more than expected due to unforeseen technical challenges or additional features being requested during development. Conclusion: system acquisition is a complex process that requires careful planning, evaluation, and execution. Businesses often face hurdles such as unclear requirements, difficult vendor selection, integration issues, resistance to change, and unexpected costs. By anticipating these challenges and addressing them proactively, organizations can successfully acquire and implement systems that improve efficiency and support growth. Next important long question is briefly discuss about system development models. System development models are frameworks used to guide the process of developing information systems. These models define the stages and steps involved in designing, developing, and implementing a system, ensuring that the project stays on track and meets its goals. Different models cater to different project needs, and each has its advantages and challenges. Common system development models. 1. Waterfall model. The waterfall model is a linear and sequential approach. Each phase must be completed before moving on to the next, such as requirements gathering, system design, development, testing, deployment, and maintenance. It's best suited for projects where requirements are well defined from the start. Example, a company implementing a payroll system with clear and fixed requirements may use the waterfall model, as the steps are predictable and sequential. 2. Agile model. Agile focuses on iterative development. The system is built in small, manageable sections, known as sprints. Each sprint typically lasts a few weeks and produces a working version of the system. This model is flexible, allowing for changes and improvements based on feedback. Example, a software development company working on a mobile app might use Agile to roll out features incrementally, getting user feedback and making adjustments after each sprint. 3. Spiral model. The spiral model combines elements of both the waterfall and Agile models. It emphasizes risk assessment and iterative development. The system is developed in cycles, where each cycle involves planning, design, implementation, and risk evaluation. Example, a company developing a new e-commerce platform may use the spiral model, focusing on gradual releases while continuously evaluating potential risks, like security concerns. 4. V model, verification and validation. The V model is an extension of the waterfall model, where each development phase corresponds to a testing phase. For example, once the system design is complete, the system is tested against the specified requirements. It emphasizes validation at every step of the development process. Example, a healthcare management system might use the V model to ensure that every stage of system development is followed by specific validation, ensuring compliance with regulatory standards. Conclusion, system development models provide structured approaches for designing and building software. Whether using the waterfall, agile, spiral, or V model, each model offers specific advantages depending on the project's needs, such as clear requirements or flexibility for iterative changes. Choosing the right model helps ensure that the system meets business objectives, is delivered on time, and operates efficiently. Next important long question is write a note on system development life cycle with suitable illustrations. The system development life cycle, SDLC, is a structured approach to developing information systems. It outlines the stages that a system goes through from conception to implementation and maintenance. The SDLC ensures that the system meets business needs, stays within budget, and is delivered on time. Here's a breakdown of the stages with an example for better understanding. 1. Planning. The first stage involves identifying the need for a new system, understanding the problem, and setting goals. This includes budgeting and scheduling the project. Example, a retail company identifies the need for an inventory management system due to frequent stockouts. They define the goals and set a timeline for the project. 2. Feasibility study. During this stage, the feasibility of the project is assessed in terms of technical, operational, and financial factors. A decision is made whether the system is worth pursuing. Example, the retail company evaluates whether they have the technical expertise to develop the system and whether the cost fits their budget. 3. System design. In this phase, the system's architecture, database design, user interface, and other technical aspects are created. Detailed specifications are prepared for developers. Example, the retail company works with developers to design how the inventory system will work, including how products will be tracked, reported, and updated. 4. Development. This is the actual coding phase, where the system is built according to the design specifications. The developers create the system's features and functionalities. Example, The development team starts building the inventory management system, integrating barcode scanning features, real-time stock tracking, and reporting tools. 5. Testing. Once development is complete, the system undergoes rigorous testing to ensure it works as expected. Any issues or bugs are identified and corrected. Example, the company tests the inventory system to ensure that stock updates happen in real time and that reports are accurate. 6. Implementation. In this phase, the system is deployed and made operational. Training is provided to users, and the system is fully integrated into business processes. Example, the retail company trains employees on using the new inventory system and goes live with it in their stores. 7. Maintenance. After implementation, the system enters the maintenance phase, where it is updated, improved, and supported over time. Example, the retail company regularly updates the inventory system to add new features or fix issues as they arise. Conclusion. The SDLC is crucial for creating systems that meet business needs and are delivered efficiently. Each phase of the cycle ensures that the system is thoroughly planned, developed, tested, and maintained. By following the SDLC, organizations reduce risks, improve quality, and ensure that the system delivers value. Next important long question is brief on the verification and validation model, V model, of system development cycle. The verification and validation, V model, is a structured approach to system development that emphasizes testing and validation at each stage of the development process. It is an extension of the traditional waterfall model, where each phase of development corresponds to a specific phase of testing. The V model is called so because its process resembles the letter V, with development steps on the left side and corresponding testing steps on the right. Stages of the V model. 1. Requirement analysis. This is the first stage where the system's requirements are gathered and documented. Verification. The focus is on ensuring that the requirements meet the business needs and are feasible. Validation. Testers ensure that the requirements are clear and well understood before moving to design. Example, a company may define requirements for a customer management system, ensuring that the system can track customer interactions, preferences, and support tickets. 2. System design. The system architecture and high-level design are created, including database structures and system components. Verification. Check that the design fulfills all functional and non-functional requirements outlined in the earlier phase. Validation. The design is reviewed to ensure that it meets the user needs as specified in the requirements. Example, the design of the customer management system is reviewed to ensure scalability, security, and data accuracy. 3. Detailed design. A more detailed breakdown of system components is done in this phase, with coding specifications and UI design. Verification. The detailed design should be checked to ensure it is consistent with the system design. Validation. Ensure that the design will meet the end user's requirements. 4. Implementation. Development. The actual system is built according to the design specifications. Verification. Ensure that the system is being built correctly according to specifications. Validation. Developers work to ensure that the code aligns with user needs and system design. 5. Testing. Testing is conducted to check if the system works as expected. Verification ensures that each module or component works as designed. Validation ensures that the entire system meets business and user requirements. Example, the customer management system is tested to ensure that it tracks customer interactions properly and generates accurate reports. 6. Deployment and maintenance. After successful testing, the system is deployed for actual use. Maintenance follows to fix bugs and improve the system over time. Example, after deployment, the system is maintained by providing updates and patches as needed. Conclusion, the V model emphasizes a systematic approach to testing and validation. Each phase of development is paired with a corresponding phase of testing, which ensures that the system meets both functional and user requirements. This approach reduces risks and improves the quality of the system, making it ideal for projects where accuracy and reliability are crucial, such as healthcare or finance applications. Next important long question is, what is prototype iterative model and when should we use it? Explain the process of iterative model. The prototype iterative model is a software development model that focuses on building a prototype, a preliminary version of the system, early in the development process. This prototype is then refined through multiple iterations based on user feedback until the final system is developed. The model allows users to interact with the system at an early stage, providing valuable feedback for improvements. When to use the prototype iterative model? The prototype iterative model is best used in situations where requirements are unclear, when the end user's needs are not fully understood. Building a prototype helps clarify requirements as users interact with it. Frequent changes. If the project is expected to evolve with changing requirements, prototyping allows flexibility to adapt to those changes. User feedback is essential, when user involvement and feedback are crucial for shaping the system. Process of the iterative model. 1. Requirement gathering. Initially, basic requirements are gathered from users, but not in detail. These requirements help in creating the first prototype. Example, in a healthcare system, initial requirements might include basic functionalities like patient registration, appointment scheduling, and basic medical history tracking. 2. Prototype development. A simple, working version of the system, the prototype, is developed based on the gathered requirements. It's not fully functional but demonstrates the core features. Example, a prototype of the healthcare system might allow users to input patient data and view appointments, but without advanced features like detailed medical records. 3. User evaluation and feedback. Users interact with the prototype and provide feedback on its functionality, features, and interface. This feedback helps identify what's working and what needs improvement. Example, healthcare professionals might provide feedback on how easy it is to enter patient information or suggest additional features, such as alerts for appointment reminders. 4. Refinement of the prototype. Based on user feedback, the prototype is refined and improved in the next iteration, adding new features or making changes to existing ones. Example, the system might be updated to include a more user-friendly interface or better patient record management based on feedback. 5. Repeat the cycle. The process of developing the prototype, getting feedback, and refining continues through several iterations until the system is fully developed and meets user needs. Example, the healthcare system goes through several iterations, gradually adding complex features like medical record management, prescriptions, and billing. 6. Final system delivery. After several iterations and refinements, the final system is developed and deployed. Example, the healthcare system is now fully functional and ready for use in hospitals, with features tailored to user needs. Conclusion, the prototype iterative model is ideal when the user requirements are not completely clear at the start or when changes are expected throughout the development process. By building and refining prototypes through iterative feedback, the model ensures that the final product aligns closely with user expectations and business needs. It's especially useful for projects where flexibility and user interaction are key to success. Next important long question is explain how evaluation and maintenance of IS takes place. Evaluation and maintenance of information systems, IS, are crucial for ensuring that the system continues to function effectively and remains aligned with the organization's needs over time. These processes occur after the system has been implemented and focus on ensuring long-term usability, efficiency, and relevance. Evaluation of information systems. Evaluation involves assessing how well an information system meets the defined objectives, user needs, and performance standards. It is done regularly to determine if the system is performing as expected. 1. Performance monitoring. The system's performance is measured against key metrics such as speed, accuracy, and reliability. For example, a retail company might evaluate how quickly its inventory management system updates stock levels after a sale. 2. User feedback. Gathering feedback from end users is essential. Users may report issues, suggest improvements, or identify new needs. For instance, a customer support team might suggest additional reporting features in a CRM system. 3. Business impact. The system's impact on business processes is assessed. This includes evaluating whether the system has improved efficiency, reduced costs, or enhanced decision-making. For example, a financial management system might be evaluated based on how it improves budgeting accuracy and reduces processing time. 4. Compliance and security. Evaluating the system for compliance with industry regulations and security standards is critical. For example, healthcare information systems are evaluated to ensure they comply with privacy laws like HIPAA. Maintenance of information systems. Maintenance involves making updates and adjustments to the system to ensure its continued effectiveness. It can be divided into 3 types. 1. Corrective maintenance, fixing bugs and issues that arise during system operation. For example, if a user discovers that the system crashes when accessing a specific report, corrective maintenance would address this bug. 2. Adaptive maintenance, modifying the system to accommodate changes in the business environment, technology, or user needs. For example, updating a payment system to support new mobile payment methods like Apple Pay. 3. Perfective maintenance, enhancing the system's performance or adding new features. This might include improving the user interface or adding new functionalities based on user feedback. For example, a social media platform might enhance its recommendation algorithms to provide better content suggestions. 4. Preventive maintenance, taking steps to prevent future problems, such as optimizing system performance, upgrading software, or updating security protocols. Example, consider an e-commerce platform. After its launch, the company evaluates the system's performance, such as response times during peak hours, and collects feedback from customers and staff. Based on this feedback, the company performs maintenance, like fixing bugs, corrective maintenance, upgrading the payment gateway, adaptive maintenance, and enhancing search functionality, perfective maintenance. Conclusion: the evaluation and maintenance of information systems are ongoing processes that ensure the system remains efficient, relevant, and aligned with organizational needs. By continuously monitoring performance, gathering feedback, and making necessary adjustments, businesses can maximize the value of their IS and ensure that it continues to support their goals effectively. Unit 4 First important short question is define system design. System design is the process of creating the architecture of an information system, focusing on how it will function, how components interact, and how the system will meet business needs. It involves defining hardware, software, interfaces, and data flow. There are two main types: high-level design, which outlines the system's overall structure, and detailed design, which specifies the individual components. Example: for an online store, system design includes defining the user interface for shopping, the backend database for storing product information, and the server architecture that handles user requests. In conclusion, system design ensures the system is structured to meet specific goals and function smoothly. Unit 4 First important long question is explain about system development and organizational change. System development and organizational change are closely related concepts in the world of business and technology. Let me break them down with a simple explanation and example. System development is the process of creating or improving software systems to meet the needs of a business or organization. This includes planning, designing, coding, testing, and deploying new systems or making upgrades to existing ones. The goal is to ensure that the system aligns with the organization's goals and makes operations more efficient. Organizational change refers to the adjustments or transformations an organization undergoes to improve its structure, processes, or culture. This could involve changes in the way people work, adopting new technology, or altering roles and responsibilities. Organizational change is often necessary for organizations to remain competitive and adapt to new challenges. The relationship between system development and organizational change: when an organization develops or implements a new system, it often triggers organizational change. For example, a company may introduce a new customer relationship management (CRM) system to improve how they interact with customers. This system development will likely require changes in how employees work, the roles they perform, and the workflows they follow. Employees might need to learn new software, management might need to redefine how teams collaborate, and new strategies might be developed for customer engagement. Example: let's say a retail company decides to implement an inventory management system to streamline how they track and manage stock. The new system will automate many tasks, reducing manual errors and increasing efficiency. However, this will also require organizational change. Employees need training to use the system, managers must adjust their workflows, and the organization might have to shift its decision-making processes based on the data the new system provides. Conclusion: in summary, system development and organizational change are interconnected. As new systems are developed, they often drive changes within the organization, influencing roles, processes, and culture. For successful implementation, businesses need to carefully manage both the technical and human aspects of change. Next important long question is brief on business process redesign. Business process redesign (BPR) is a strategy used by organizations to analyze and improve their existing processes, aiming to enhance efficiency, reduce costs, and better serve customers. It involves rethinking and reshaping the way business tasks are carried out, often with the help of new technology or innovative practices. What is business process redesign? BPR focuses on making significant changes to core business processes rather than making incremental improvements. It usually involves starting from scratch, analyzing existing workflows, identifying bottlenecks or inefficiencies, and redesigning processes to achieve better results. The goal is to deliver higher value, faster service, and lower operational costs. Example of business process redesign: let's take an example of a hospital. Traditionally, patients would visit different departments for multiple steps like registration, payment, diagnosis, and treatment. This process could be slow and frustrating for patients and staff alike. With BPR, the hospital might redesign this process by creating an integrated digital system where patients can check in, pay bills, schedule appointments, and receive treatments more seamlessly. Instead of the old fragmented system, everything could be handled through a centralized platform, reducing waiting times and eliminating unnecessary paperwork. This redesign not only improves the patient experience, but also makes the hospital more efficient and cost-effective. Why is business process redesign important? BPR is important because it helps organizations adapt to changing business environments, meet customer expectations more effectively, and stay competitive. By rethinking and improving business processes, companies can achieve greater flexibility, faster decision-making, and a stronger ability to innovate. Conclusion: business process redesign involves rethinking and revamping existing processes to improve efficiency, cut costs, and enhance customer satisfaction. By focusing on substantial changes rather than small adjustments, organizations can create streamlined operations that drive better performance. Whether in healthcare, manufacturing, or retail, BPR helps businesses optimize how they work, providing both immediate and long-term benefits. Next important long question is explain about systems analysis. Systems analysis is the process of examining and understanding a business or organizational system to identify its components, how they interact, and how they can be improved or optimized. It focuses on understanding the existing system, determining what works and what doesn't, and figuring out what changes are necessary to meet specific goals. What is systems analysis? In simple terms, systems analysis is like taking a deep look at a machine or a process to see how it operates, where it's failing, and what parts need adjustment to make it run better. This process helps organizations understand their current systems and make informed decisions about how to improve them or build new ones. It involves gathering information, analyzing problems, and identifying solutions. Example of systems analysis: imagine a small retail company that uses a manual inventory system to track stock levels. The system is outdated, leading to frequent mistakes, such as orders being processed incorrectly or stock running out unexpectedly. A systems analyst would come in and study the current inventory process. They would ask questions like, how do employees track inventory now? Where do mistakes happen most frequently? What tools are being used? Example, spreadsheets, paper logs. How do these problems affect the business? After gathering the necessary data, the analyst would evaluate the system's weaknesses, such as the manual tracking method causing errors or taking too much time. They might recommend a new, automated inventory management system that would streamline the process, reduce errors, and make real-time updates to stock levels. Why is systems analysis important? Systems analysis is crucial because it helps organizations understand their systems in depth, leading to more efficient operations. It ensures that the solutions implemented will address real problems, align with business goals, and improve overall performance. Conclusion: in summary, systems analysis involves thoroughly studying and understanding a system to identify its flaws and determine how to improve it. It's a critical step for businesses looking to optimize their operations, whether that means enhancing an existing system or creating a new one. By conducting a careful analysis, organizations can ensure that they implement solutions that effectively meet their needs and drive success. Next important long question is, what is system design? Explain the objectives and benefits of system design. System design is the process of planning and creating the architecture of an information system. It defines how the system will work, including its components, structure, and how they will interact to meet the organization's needs. The goal is to transform the system requirements, identified during system analysis, into a blueprint that can be developed, implemented, and maintained. Objectives of system design. The primary objectives of system design are 1. Create a blueprint to define the system architecture, including hardware, software, and network requirements, ensuring it aligns with business goals and user needs. 2. Ensure efficiency. Design the system to operate efficiently, minimizing waste and reducing costs. 3. Maintain flexibility. Build a system that is flexible and scalable, able to adapt to future needs and technological changes. 4. User-friendly interface. Ensure the system is easy to use for end users, providing clear and intuitive interfaces. 5. Security and reliability. Ensure that the system is secure, protects sensitive data, and is reliable, minimizing downtime or errors. Benefits of system design. 1. Improved problem solving. System design allows for the identification of potential issues early on, helping to prevent problems during development or implementation. 2. Better resource utilization. A well-designed system maximizes the use of available resources, such as processing power, storage, and human resources. 3. Scalability. Good system design makes it easier to scale the system as the organization grows or as demands change, allowing for future upgrades or expansions without significant disruptions. 4. Cost efficiency. By planning the system's structure and components ahead of time, businesses can avoid costly redesigns and inefficient processes later. Example of system design. Let's say a university wants to create an online learning management system, LMS. During system design, the team will define the architecture, such as the database for storing student information, the user interface for students and faculty, and security protocols for protecting personal data. The design would focus on creating a system that is easy to use, handles a large number of users, integrates with existing systems, like the student registration system, and scales as the university expands its offerings. Conclusion. In conclusion, system design is about carefully planning how a system will function to meet organizational needs. Its objectives are to ensure efficiency, scalability, usability, and security. By creating a solid system design, businesses can avoid problems, use resources effectively, and ensure that the final system meets both current and future demands. Next important long question is discuss the pros and cons of system development process. The system development process is the set of steps used to create or improve software systems. It involves phases like planning, analysis, design, development, testing, and deployment. Each approach to system development, example, waterfall, agile, has its own pros and cons, but let's explore the general advantages and disadvantages of this process. Pros of the system development process. 1. Structured approach. The process provides a clear framework, ensuring that each step is completed in order. This reduces confusion and helps teams stay organized. Example, in waterfall methodology, each stage, analysis, design, coding, is completed before moving to the next, ensuring thorough work at every step. 2. Improved communication. A structured process fosters better communication among team members, stakeholders, and customers. Example, regular meetings during the system development process allow the team to get feedback early and make adjustments. 3. Clear milestones. Breaking down the project into phases makes it easier to track progress and measure success at each stage. Example: if the analysis phase is completed successfully, the team knows it's time to move on to design and development. 4. Quality control, testing and review phases allow teams to catch and fix bugs or issues before deployment, ensuring a higher quality final product. Cons of the system development process. 1. Time-consuming. The structured process can be slow, especially if each phase needs to be completed before moving to the next. Example: in the waterfall method, once the design phase is done, returning to it for adjustments can be difficult and time-consuming. 2. Rigid. Some methods, like waterfall, are inflexible and may struggle to adapt to changes once the project is underway. This can be problematic if requirements change mid-project. Example: if a business's needs shift during development, the team may need to redo major portions of the work, leading to delays and increased costs. 3. High risk of failure. If early stages, like analysis or design, are flawed, it can affect the entire project, leading to significant setbacks or failure. Example: if system requirements aren't fully understood during analysis, the design may be poor, resulting in a system that doesn't meet the user's needs. Conclusion: the system development process provides structure, organization, and quality control, which can lead to successful project outcomes. However, it can also be time-consuming and rigid, with the potential for failure if not carefully managed. Businesses should weigh these pros and cons when deciding on a development approach to ensure the best outcome for their project. Next important long question is: what is system development? Explain any two system development models. System development is the process of creating, designing, and maintaining software systems that meet the specific needs of an organization. It involves analyzing business requirements, designing solutions, coding, testing, and deploying the system. The goal is to improve efficiency, solve problems, or automate tasks within the organization. There are several models used to manage the system development process. These models provide structured approaches to developing systems, each with its strengths and weaknesses. Below are two common system development models. 1. Waterfall model. The waterfall model is one of the oldest and simplest system development models. It follows a linear, sequential approach where each phase must be completed before moving on to the next. The stages typically include requirement gathering, system design, implementation, testing, deployment, and maintenance. Example: if a company wants to develop a new payroll system, they would start by gathering all the requirements, example, tax calculations, employee data. Then, they design the system, write the code, test it, and finally deploy it. The process does not allow for revisiting previous phases unless there's a major issue, which can make it rigid. Pros: clear structure and easy to manage. Simple to understand and implement. Cons: inflexible if requirements change mid-process. Can be slow, especially for large projects, because you can't move forward until each stage is completed. 2. Agile model. The agile model is an iterative and flexible approach to system development. Instead of following a strict linear sequence, Agile breaks the project into small, manageable parts or sprints. Each sprint typically lasts 1 to 4 weeks and results in a working product. Feedback from users and stakeholders is incorporated after every sprint, making it easier to adapt to changes. Example: if a company is developing a mobile app, they may start by creating a basic version of the app with limited features. After each sprint, the app is updated with new features or improvements based on user feedback, making it more flexible and adaptive to changing needs. Pros: highly flexible and adaptable to change. Encourages constant feedback and improvement. Cons: can be chaotic if not managed well. Potential for scope creep, the project expanding beyond initial goals. Conclusion: system development is essential for creating software systems that meet business needs. The waterfall model provides a clear, structured approach but can be inflexible, while the agile model allows for flexibility and continuous improvement, though it requires more management. Choosing the right model depends on the project size, complexity, and the need for flexibility. Next important long question is: write a note on new approaches for system building in the digital firm era. In the digital firm era, organizations are increasingly relying on technology to improve efficiency, enhance customer experiences, and stay competitive. Traditional approaches to system building are no longer sufficient to meet the fast-paced and ever-changing demands of businesses. Therefore, new approaches for system building have emerged, focusing on flexibility, speed, and integration with modern digital tools. 1. Agile development. Agile development is a flexible and iterative approach that breaks the system development process into small, manageable parts, called sprints. Each sprint focuses on delivering a working component of the system, allowing for rapid prototyping and frequent user feedback. This ensures that the system evolves based on real-time needs and can adapt to changes in business requirements. Example: in a retail company's website redesign, Agile allows the development team to launch a basic version of the site first, then gradually add new features like online payments, user reviews, and personalized recommendations based on customer feedback. 2. Cloud computing. Cloud-based systems are a new approach that provides flexibility and scalability. Cloud services allow businesses to build and deploy applications without worrying about the physical infrastructure. This reduces costs, increases accessibility, and allows for faster updates and collaboration across different locations. Example: a small business using a cloud-based customer relationship management (CRM) system can access it from anywhere, track customer interactions, and scale up their subscription as the business grows, without investing heavily in physical servers. 3. Low-code and no-code platforms. These platforms allow users to create applications without needing extensive coding knowledge. By using visual interfaces and pre-built templates, business users, even those without technical backgrounds, can develop systems or apps that meet their needs quickly and with minimal technical expertise. Example: a marketing team in a company could use a no-code platform to create a campaign management tool, saving time and reducing reliance on the IT department for every small change. Conclusion: the digital firm era demands faster, more adaptable, and scalable systems. Approaches like agile development, cloud computing, and low-code platforms address these needs by enabling rapid deployment, continuous iteration, and cost-effective solutions. These new approaches empower businesses to stay ahead in a fast-moving digital world. Next, fifth unit. First important short question is: describe cyber laws' importance in India. Business cyber laws in India are essential for ensuring safe and secure online business operations. They regulate activities like data protection, cybercrimes, and intellectual property rights. For example, the Information Technology Act 2000 addresses issues like hacking, data theft, and e-commerce disputes, ensuring that businesses can operate with confidence. A key law, the Personal Data Protection Bill, helps protect customers' personal information, fostering trust. In conclusion, cyber laws safeguard both businesses and consumers, enabling the digital economy to grow securely by providing a legal framework to handle cyber-related challenges effectively. Next, fifth unit, first important long question is explain about cyber law in India. Cyber law in India refers to the legal framework that governs the use of the internet, online transactions, data protection, and digital communication. It is essential for regulating online activities and ensuring the security and privacy of individuals, businesses, and government entities in the digital world. Key cyber laws in India. 1. Information Technology Act, 2000, IT Act. The IT Act is the primary legislation governing cyber activities in India. It was enacted to promote e-commerce, digital transactions, and secure electronic communication. The Act provides legal recognition to electronic contracts, digital signatures, and online transactions, making them legally valid. It also defines cybercrimes and prescribes penalties for offenses like hacking, identity theft, and cyberstalking. Example: if someone hacks into a bank's online system and steals money, the IT Act provides the legal framework for prosecuting the hacker. 2. Cybercrimes and punishments. The IT Act defines various cybercrimes, such as hacking, Section 66, cyberstalking, Section 66A, and identity theft, Section 66C. These laws ensure that people who commit online offenses can be penalized with fines, imprisonment, or both. Example: if a person creates a fake online identity to defraud someone, they can be punished under the IT Act for identity theft or impersonation. 3. Data protection and privacy. Cyber laws also cover aspects related to data protection and privacy. The Personal Data Protection Bill is being proposed to regulate how personal data of individuals is collected, stored, and processed by organizations. This law would require businesses to get consent before collecting data and to ensure its security. Example: an e-commerce website must inform customers how their personal details, like address and credit card information, will be used and stored, ensuring privacy and security. 4. Regulation of online content. The IT Act also provides provisions for regulating online content, ensuring that harmful, offensive, or illegal material is removed from the internet. Websites or platforms can be held liable for hosting or spreading unlawful content. Example: social media platforms can be held accountable if they fail to remove hate speech or defamatory content. Conclusion: cyber law in India is crucial for managing the growing digital landscape, providing legal support for e-commerce, online privacy, and data protection, while also fighting cybercrimes. With the increasing reliance on digital technology, strong cyber laws are essential to create a secure and trustworthy online environment for individuals and businesses. Next important long question is: who are hackers and cyber criminals? Explain types of hackers and cyber criminals. Hackers and cyber criminals are individuals who exploit vulnerabilities in digital systems for various malicious purposes. Hackers typically access computer systems without authorization, while cyber criminals engage in illegal activities online, often for financial gain, espionage, or other harmful objectives. Types of hackers. 1. White hat hackers, ethical hackers. White hat hackers use their skills to help organizations improve their security. They are authorized to test systems for weaknesses, identify vulnerabilities, and fix them before malicious hackers can exploit them. Example: a cybersecurity consultant hired by a bank to perform penetration testing on the bank's online platform to identify and fix security gaps. 2. Black hat hackers, criminal hackers. Black hat hackers are the bad guys who break into systems illegally to cause harm, steal information, or exploit vulnerabilities for malicious purposes. They often use their skills for financial gain or to damage organizations. Example: a hacker breaking into a company's database to steal customer information, like credit card details, for fraudulent activities. 3. Grey hat hackers. Grey hat hackers lie between white and black hats. They may hack systems without permission but typically don't have malicious intentions. Instead, they report vulnerabilities to the owner, though their actions are still illegal. Example: a hacker who finds a flaw in a website and notifies the company about it, but without prior authorization to test the system. 4. Hacktivists. Hacktivists use hacking as a form of protest or to promote social or political causes. They often target organizations or governments they disagree with, intending to expose wrongdoings or disrupt operations. Example: a group of hackers attacking a government website to protest against a policy or decision. Types of cybercriminals. 1. Phishers. Phishers use fraudulent emails, websites, or messages to trick individuals into revealing sensitive information like usernames, passwords, and financial details. Example: a fake email pretending to be from a bank asking customers to verify their account details, which are then stolen. 2. Ransomware attackers. These criminals deploy malicious software that locks users out of their systems or data and demands a ransom to restore access. Example: a hospital's computer system being locked by ransomware, with attackers demanding payment to unlock patient data. 3. Identity thieves. Cybercriminals may steal personal information to commit fraud, open unauthorized accounts, or perform illegal transactions under someone else's name. Example: a criminal stealing a person's identity to apply for loans and run up debt in the victim's name. Conclusion: hackers and cybercriminals pose significant risks to digital security, but they can be divided into categories based on their intentions. White hat hackers work to protect, while black hat hackers and other cybercriminals engage in illegal activities. Understanding the different types helps individuals and businesses stay aware of potential threats and better protect themselves against cybercrime. Next important long question is discuss about inter-network security defenses. Inter-network security defenses refer to measures taken to protect networks from unauthorized access, cyber threats, and attacks while allowing secure communication between different networks, internally or externally. These defenses are crucial in maintaining the integrity, confidentiality, and availability of information as data travels across interconnected networks, such as the Internet or intranets. Key types of inter-network security defenses. 1. Firewalls. A firewall is a security system that monitors and controls incoming and outgoing network traffic. It acts as a barrier between a trusted internal network and untested external networks, like the Internet. Firewalls use predefined rules to block malicious traffic while allowing legitimate communication. Example: a business uses a firewall to prevent unauthorized access from the Internet to its internal servers while permitting employees to access authorized websites and applications. 2. Intrusion detection systems, IDs, and intrusion prevention systems, IPS, and IDs monitors network traffic for suspicious activity or potential security breaches, while an IPS not only detects threats but also actively prevents them by blocking malicious activity. Example: if a hacker tries to exploit a vulnerability in a network, an IDs will alert the security team and an IPS will block the attack to prevent any damage. 3. Virtual Private Network, VPN. A VPN is a secure, encrypted connection that allows users to connect to a network remotely while protecting their data from potential interception. It creates a private tunnel within a public network, like the Internet, making it difficult for unauthorized parties to access the transmitted data. Example, employees working from home can connect to their company's network through a VPN, ensuring that their work data is encrypted and secure from hackers. 4. Network Access Control (NAC). NAC restricts access to the network based on predefined security policies. It ensures that only authorized devices, like computers or smartphones, can connect to the network, preventing unauthorized devices from gaining access. Example, an organization uses NAC to ensure that only employees' devices with up-to-date security software can access its internal network. 5. Encryption. Encryption is the process of converting data into a coded format to prevent unauthorized access during transmission. It ensures that even if data is intercepted, it cannot be read or used without the proper decryption key. Example, a financial institution encrypts all customer transactions, ensuring that even if data is intercepted, it remains secure and unreadable to hackers. Conclusion. Inter-network security defenses are essential for safeguarding digital communications and protecting sensitive data as it moves between different networks. Technologies like firewalls, IDs, IPS, VPNs, NAC, and encryption help mitigate risks from external and internal threats, ensuring that businesses can operate securely in a connected world. These defenses form a robust security infrastructure that minimizes vulnerabilities and enhances the protection of critical systems. Next important long question is discuss about other security measures. Other security measures refer to additional strategies and tools that help protect information systems and data beyond basic network defenses. These measures are designed to prevent unauthorized access, ensure data integrity, and safeguard against various types of cyber threats. 1. Two-factor authentication. Two-factor authentication adds an extra layer of security by requiring two forms of verification before granting access to an account or system. Typically, this includes something the user knows, a password, and something the user has, a mobile phone or security token. Example, when logging into an online banking account, after entering the password, the user receives a one-time code on their phone, which must be entered to complete the login. 2. Antivirus and anti-malware software. Antivirus and anti-malware programs help detect, prevent, and remove malicious software, malware, such as viruses, ransomware, and spyware, from a computer or network. These tools scan files and programs for harmful code and block or quarantine it. Example, an employee's computer is equipped with antivirus software that regularly scans for viruses and prevents malicious attachments from infecting the system. 3. Regular software updates and patching. Regular software updates and security patches are critical to fixing vulnerabilities that hackers can exploit. Developers frequently release updates to address security flaws, so it's important to install them promptly to keep systems protected. Example, a company's IT team installs security patches on all computers to protect against newly discovered vulnerabilities in their operating systems and applications. 4. Data backups. Data backups ensure that important files and systems can be restored in case of a cyber attack, like ransomware or hardware failure. Backups should be done regularly and stored securely, preferably in a separate location or in the cloud. Example, a small business backs up all its customer data to a secure cloud service, ensuring that if their local servers are compromised, they can restore the information from the backup. 5. Security awareness training. Educating employees about security risks, best practices, and how to recognize phishing scams or social engineering attacks is a key component of a strong security strategy. Employees are often the weakest link in cybersecurity, so training them to spot threats helps reduce risk. Example: an organization provides training to staff on identifying phishing emails and advises them not to click on suspicious links or attachments. Conclusion: while traditional network defenses like firewalls and VPNs are important, additional security measures such as two-factor authentication, antivirus software, software updates, data backups, and employee training are equally essential. These measures help create a layered defense, making it more difficult for cybercriminals to breach systems and ensuring the organization's data remains safe and secure.